The objective of our experiment was to pulverize coal with particle size 10 to 15 mm to dust with particle size 0 to 300 micron and mix that with water and plasticizer to make coal water fuel, CWF. The experiment was performed using the AVS 150 Vortex layer device. The main principle of making coal water fuel is consistent pulverization of coal with specified parameters and precise dosing of additives to improve rheological properties and combustion stability. For the purposes of this test, we took 600 grams of coal, 400 milliliters of purified water, and polyphosphate as plasticizer. For demonstration, the experiment was performed in a reactor instead of in a continuous stream. The optimal characteristics of magnetic induction for this process were measured using a multi-Tesla meter. In the first stage, we ground 10 to 15 mm coal in a dry environment. The pulverization was performed for 2 minutes using ferromagnetic particles 2 mm in diameter and 20 mm in length. The results of the pulverization were evaluated using 316, 160 and 50 micron laboratory sieves. 96% of the sample passed through the 316 micron sieve, 60% passed the 160 micron sieve, and only 10% passed the 50 micron sieve. In the second stage, we pulverized the same 10 to 15 mm coal fraction with water, making the coal water slurry in the process. Pulverization and mixing took 2 minutes. The results were evaluated with sieves after drying the sample. 98% of the sample passed through the 316 micron sieve, 86% of the sample passed the 160 micron sieve, and 35% of the material passed the 50 micron sieve. In the third stage, we mixed coal previously pulverized for 2 minutes. The mixing took 30 seconds. Stability of the resulting fuel was checked for 5 days. Separation of water and coal was negligible. CWF stability can be maintained by periodic recirculation in storage vessels. Using plasticizer is not required. The results of the pulverization were again tested by sieves after drying the sample. 98% of the sample passed the 316 micron sieve, 90% passed the 160 micron sieve, and 63% of the sample passed the 50 micron sieve. The results of the experiment led to the following conclusions. Average capacity of the AVS 150 device in a continuous stream will be 3 cubic meter per hour, with 9 kilowatt-hour power consumption. The use of plasticizer is not required due to the intensive mixing in our device. Operation of the devices can be made continuous, since additional ferromagnetic particles to replace the worn ones are added automatically by a portioning device. For a more comprehensive research of our product coal water fuel, we constructed a burner with a sprayer. The burner is designed to create finely dispersed particles in a spray to ensure quick evaporation of water and stabilization of combustible gas circulation in the area of combustion. In the next video, we will describe the combustion process and show the parameters of melting temperature and combustion calorific value.